In this video, I'm going to show you how can we use long short-term memory algorithm and machine learning using Python to predict stock price. So let's go. So first, let's start with some import. So in this project, we're going to need math library, NumPy, pandas, and pandas data reader. We're also gonna need scikit-learn preprocessing, and we're gonna import min-max scalar. Next, we're going to import sequential from keras models and import dense and LSTM from keras layers. Next, we are going to import matplotlib. Using pandas data reader, I'm going to import my stock data from Yahoo. The data that I'm going to use is Apple stock, and the start date it's from 2013 to 2019. So as you can see, my data frame has multiple columns. It has the date, the high price, the low price, the open price, the close price, the volume. So in this project, I'm gonna focus more on the close price, since it's the price that I'm going to predict. Here we can notice a trend. So it seems like the Apple stock was doing great during all these years, and also it's increasing. We can see that it has been increasing over the years. Since our prediction is going to be in the closing price, so using filter function, I will create a new data frame with only the close price column. Also, since I'm going to normalize the data later, so I'm going to convert my data frame to NumPy array using value function. Next step, I will prepare the training data. So I choose to use 70% of data in training. So I'm going to create training data size and using the math library and the self function, I'm gonna get 70% of my data set for training. So here my data set has 1761 values, and the 70% of this total is 1233. Using min-max scalar, I'm going to normalize the data. It's a good practice to normalize the data and make all the values between 0 and 1, so we can use them in our deep learning algorithm. So here in the results and the output of the array, I can see that all the values are between 0 and 1. So since we are using long short-term memory network, we must specify the shape of the input. So the LSTM must be in 3-dimensional. So in the 3-dimensional are number of samples, the time of steps, and the features. So the samples is the 70% of my data set that I already chose, and the time of steps is the point of observation in the sample. So I choose to have 60 observation of the sample. For the feature, we're gonna see next how we're gonna choose the feature. Next step, we're going to create a training dataset which has values from 0 to training data size, which gave us the 70% of our dataset. Next, we are going to split the training data into X train and Y train. The X train, it's the independent training variable or the training feature, and the Y is the dependent variable or the target variable. So since we need 60 observation of our data or from our training data, so I need to create a loop for E in the range between 60 to the size or the total size of the training data. So for X, we're going to append the past 60 values. So the X train data will start from position I minus 60 to I position. So I'm not including I. And the Y train data will contain the value in the 61 position. So X will have 60 values from 0 to 59. And Y will have the 61's value in the 60 position. And this is the value that we are looking to predict from using our model. Here I added the if condition, so I can print the X train and the Y train. I choose I to be inferior or equal to 61 just to see how my observation are created. You can play with this number so you can see just how the steps are printed. Next step, we're going to convert the X train and the Y train to an NP array so we can use it to train the LSTM model. The last step in this video, we are going to reshape the data. So the LSTM model expects to input the three-dimensional in the form of number of samples, number of steps, and number of features. Our data now is in 2 dimension, so we will convert it to 3D or 3 dimension and add the number of features, which is 1, which represent the closing price. So here as a result we have 3 dimension, our data set in 3D. So we have the number of samples, which is 1173. We have the number of step, which is 60, and the number of features, which is 1.